Hello everyone, let's talk about easy problem on Leetcode today. Evaluate Boolean binary tree, Leetcode 2331. In this, we are given a root of a full binary tree, and this binary tree can have only 4 types of node. Leaf nodes can be 0 or 1, representing false and true, and non-leaf nodes can be 2 and 3, where 2 represents the Boolean OR operation and 3 represents Boolean AND. And in the end, what we have to do is like we have to run this expression and evaluate the root node which is given to us and return the Boolean value as an answer. So let's jump into the example. So in this case, we are given like 2 is like OR operation, right? And 3 is AND operation. So 2 is like OR here, as we can see, and then we have its child 1 and 3. So 1 means true, right? And 3 means AND again. And then we so when we are this is how the tree is represented. And when we run the what you say the root of operation from the root node, so first thing we do is like we first find out, okay, we have to first process the child, because childs have real values like 0 and 1, and then we have to go to the operator level, like in this case 2 and 3, or and AND. So we can say false and true is false, right? So this becomes this child, and then eventually this will be like, and then true or false is true, right? Because if any of the gate is returning true value or it's on, we will return true in case of our gate. So and now let's jump into the solution space. So as we can see, I think it looks like some form of what you say post audit traversal, where we have to get the values from child first and then processes at the node level. What we can do is like at each, we can actually write this recursive DFS, what you say, solution. So for each node, what we have to do is like we have to first process whether the value if is already leaf, that we don't have to worry about. But then when we go to the operator level, we have to either do OR operation or the AND operation, and this is how it will go up and up till we reach to the root what you say root node. So let's now jump into the code part. So I think the code is very simple. What we can do is like we can also write like a switch case kind of a thing. So if you think about it, what is like root dot value, right? So it will be either what you say 0, right? It can be either 0 or it can be 1, or it can be 2, or in the worst case, when we hit the default, it can be 3, right? And now let's see what we have to do in case of 0. We have to just return false, right? Because that's what matters. Similarly, for case 1, we will return true. Now that we have processed the child node, now we will start processing the root node. And for this, we will start doing the DFS. So if it's 2, that means it's a OR operation. So we will just say, okay, evaluate this tree again with root dot left uh, or root dot right, right? Yeah. So the beauty of this is like if evaluation of root dot left comes as true, we know that in the OR operator, if any of the value is true, it does not process as the second value. So we will end the algorithm faster, and we will do the similar thing for 3. In this case, instead of using the OR operator, we will just do the what you say AND operator. And as we are returning from all the cases, I think, yeah, we don't have to do the return statement anywhere, because we have taken care of all the paths from a switch case statement. We could have also written like a if else statement, but yeah, this is a very good example of showing switch case in Java. Now let's run the code. Cool. And now we can submit this code as well. Cool. So in terms of like time complexity, because we are processing all the nodes, it will be what you say O of n. And because we are using recursive stack, we can say it's O of n. But if program interviewer is fine that the recursive stack does not count, then it's O of 1. I hope you like this solution. If it helps you, please like and subscribe, and also comment how I can do better. Thanks.